Okay, so today let's start off with partial fractions. So let me talk a bit about partial fraction. Partial fractions. So what exactly is partial fractions? So you know in AMath, you know how to combine into a single fraction. Okay? It's like, for example, if I have 2x minus 3 plus 5x over x plus 5, for example. Okay, we combine it into a single fraction, we will change them to the same denominator, right? So you will know, oh, okay, I have my common denominator x minus 3 and x plus 5. And I will know, okay, my 2 must multiply with x plus 5. And my 5x must rainbow with x minus 3. So this is how you combine into a single fraction. And then when you simplify, you get 2x plus 10 plus 5x squared minus 15x over x minus 3 and x plus 5. So we will get 5x squared minus 13x plus 10 over x minus 3 and x plus 5. So this is how you combine the single fraction in AMath. Okay? So in AMath, what you're trying to do is, from single fraction, you want to break it back into their separate fractions. That's called the topic partial fractions. Okay? So in general, you have 3 cases. Okay, case number 1 is when you have linear denominator. So let's say, okay, I don't care about my numerator. So let's say I have x minus 3 and x plus 5. Okay, I want to split it into their partial fractions. The first bracket, this is linear. Okay, case 1 is linear. So x minus 3 will give birth to a over f minus 3. X plus 5 is also linear, so it will also give birth to b over x plus 5. Okay? Case number 2. Repeated linear. So let's say I have a x plus 5 and then I have a x minus 3 squared. Okay, the first one, the x plus 5 is case 1, which is linear. Okay, x minus 3 squared, it is repeated linear. So for this, I will have 3 fractions. The x plus 5 will give birth to a over x plus 5, and this one will give birth to 2, which is b over x minus 3 to the power of 1 plus c over x minus 3 to the power of 2. Okay, so this actually will have 2. So this is the case number 2. Case 3, quadratic. Okay, quadratic. So it means, like, for example, if I have x plus 5 and then here, sorry, x plus 3, here maybe say x squared plus 1. So when you have a quadratic bracket, okay, when you have a quadratic bracket, you have to ask yourself whether you can factorize first. Okay, only if you cannot factorize, then you apply case 3. So x plus 3, as usual, it is case 1, so this will give birth to a over x plus 3. This will give birth to bx plus c over x squared plus 1. Okay, so this one give birth to this. So you only have 3 cases. Thanks for the, what's that? Is that a music note, I think? Okay, so in general, you only have these 3 cases. Okay, linear, repeated linear, or quadratic. And every time you see quadratic, make sure that you cannot factorize, then you apply case number 3. Okay, and of course, the very, very important one is always check whether it is proper or improper first. Always check for this one first. Okay, so now let's go back. Let's start a question and then we will learn along the way. Okay, this. So first, every time they say express blah 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 as a partial fractions, you need to ask yourself whether is it a proper or improper. Okay, this should have an S. Okay, so let's check at the highest degree. So my numerator highest is 3, power is 3. My denominator, if I expand, I get x squared. So you can see that the numerator power degree is bigger than the denominator. So in this case, this is improper. Okay, so in this case, you will see that this is improper. So once it is improper, the first thing you need to do is to do long division first. Understand? Long division. It must be long division first. So what do I do? Okay, so I will have to take 2x cubed. Why should I use red pen? I use blue pen. So I will take 2x cubed. Do you see that there is a missing term x squared here? So in this case, I have to put plus 0x squared because I need to leave a space for that. Then after that, minus 3x minus 1. I'm going to divide it by the denominator. But of course, before you divide, you have to expand the denominator first. Okay? So I will do it at the top. My x plus 3 and x minus 1, rainbow will give me x squared minus x plus 3x minus 3. And that will give us x squared plus 2x minus 3. So that means I'm going to divide it by x squared plus 2x minus 3. So now you need to ask yourself, what multiplied by x squared will give me 2x cubed? Okay, so we know it is 2x. So let's rainbow. 2x times x squared, 2x cubed. 2x times positive 2x plus 4x squared. 2x times negative 3 minus 6x. Put a minus and remember, always put the bracket. Okay, always put the bracket so that you will minus properly because it's subtract. Remember subtraction, we always must put bracket, correct? So the first term definitely will disappear. So I have 0 minus 4, so I have negative 4x squared minus 3x minus 6x, so it becomes plus 6x. So this is plus 3x. Okay, so bring down the last term, which is minus 1. So now you have to ask yourself, what multiplied by x squared will give me negative 4x squared? So we know we need to put minus 4. So negative 4 times this will give me minus 4x squared. Negative 4 times this will give me minus 8x. Negative 4 times negative 3 will give me plus 12. Put the minus with the bracket. The first term definitely is 0. Now you have 3 minus 8, so it is 11x. Minus 1 minus 12, so it's minus 13. This is usually it's learned in Sec 3A math under polynomial. After polynomial, they teach partial fraction. So this will be my remainder. So what you're going to do is you're going to put this in the mixed number form. So you'll put this 2x cubed minus 3x minus 1 over, put back into the bracket, x minus 1 is equals to the quotient 2x minus 4 plus the remainder, okay, over the divisor. Okay, so this is the first thing you need to do, okay, because this is an improper fraction. So when it's an improper, you got to do long division to find the quotient and then the remainder. So this is the quotient plus remainder over the divisor. So now next, you need to break this part. Now this, you will have to apply the case 1, case 2, case 3, correct? Okay, you got to apply this to split it into the fractions. So let's take a look. So I will bring this down. So you will have 11x minus 13 over x plus 3 and x minus 1. So let's take a look at the first bracket. X plus 3 is case 1. So that means this will give birth to a over x plus 3. X minus 1 is also case 1. So it will become plus b over x minus 1. So now you don't bother about this side first. This one, I want to combine this into a single fraction. So it means that my a must multiply with x minus 1, must b must multiply with x plus 3 over the two bracket, which is x plus 3 and x minus 1. So now what you need to do is, you need to compare the 11x minus 13 with the numerator. So you know, therefore, 11x minus 13 is equals to a, x minus 1 plus b, x plus 3. So your task is to solve a and b, okay? So this is suitable to, you can of course rainbow and compare coefficient, okay? You can also use substitutable values, which I personally would like to use substitutable value. So let's analyze. Okay, substitutable values means what? If I'm going to sub x equals to 1, 1 minus 1 will give me 0. So 0 times a, my a will disappear, correct? But my b will remain. So I end up having an equation solving b. Okay, so I will sub in. No, don't expand x, a and b. Okay, I usually use substitutable value. So I'm going to sub in x equals to 1. So 11, 1 minus 13 is equals to, this one will become 0, so I don't have to write, b 1 plus 3. So I have 4b is equals to minus 2. Okay, I ended up having b is equals to negative half. Okay. It's okay. I believe that you didn't fail in life, right? Okay, life is just going through different experience. Okay, it's never smooth sailing. Okay, it's just one problem, another problem. Then we just need to solve the problem when it comes. Okay. Okay, so b is equals to negative half. So I now want to solve my a, correct? So same thing, I can sub suitable value. Okay, you also can sub in any x value plus your b, and you still can solve your a. But I want to make my b disappear, so I'm going to sub in x equals to negative 3. So I'm going to sub in x equals to minus 3. So now I have 11 minus 3 minus 13 equals to a minus 3 minus 1. Minus 3 plus 3 is 0, so the b disappear. So I only left with this. So I have minus 4a equals to minus 33 minus 13, which will give me minus 33 minus 13 will give me, calculator, negative 33 minus 13 minus 46. So my a will become 23 over 2. So you see, I solved my a and b. So now what you need to do is put it back to this one. And common mistake is students, when they do the proper side, the 11x minus 13, then they forget that they still have to show the 2x minus 4. So the last statement, you will state that, therefore, the original question, 2x cubed minus 3x minus 1 over x plus 3 x minus 1 is equals to 2x minus 4 plus, now is this one, a. My a is 23 over 2. So you will write 23 over 2 with the bracket x plus 3. Okay. My b is minus half, so it's minus 1 over 2 x minus 1. And you're done. So this is express this single fraction into their partial fraction. Understand? Thanks for the nasi lemak. All good. So this is only warm up. Okay, this is AMath Sec 3 under partial fractions. So first thing, always check proper or improper. If it's improper, do the long division. After long division, you got to put them in the mixed number form. And then after that, at the proper side, you go and do the case 1, case 2, case 3. For this case, I only use case 1. Then after that, I substitutable value to find my unknown A and unknown B. And then I put back, and then I form the partial fractions. Okay, thanks for the rows. Okay, so let's move on to the next question. Thanks for the rows. Okay, next. Wait. So let's check whether this is proper or improper fraction. Okay. Look at the numerator. The highest power is square. The denominator highest power is 3. So when the numerator degree is equal or smaller than, is equal or greater than is improper. When the degree for the numerator is smaller than the denominator, it is proper. So in this question, yes, this is proper. Okay, so we will say that this is proper. The first thing, always check that it's proper or improper. Improper, yes. So now this is proper, so I can proceed to break them up. But the bad news is my denominator is not factorized yet. So we will have to factorize the denominator first. Okay, so in this case, I will use the polynomial. We will use polynomial. So we will say, I'm going to let fx equals to 2x cubed minus 4x squared plus x minus 2. So what I'm trying to do now is, I want to factorize my denominator. Okay, I want to factorize my denominator. So I let polynomial fx equals to the 2x cubed minus 4x plus x minus 2. Okay, and then I'm going to use factor theorem to find out what's one of the factor. Okay, and I get, so I'm going to try x minus 2. So we will sub into 2 cubed minus 4 2 squared plus 2 minus 2 will give us 0. So when you give you a 0, it means that there's no remainder. When there's no remainder, okay, it means that x minus 2 is a factor. So you will say, oh, so therefore x minus 2 is factor of fx. Okay, and now of course you can state that this is factor theorem, the reason why. So now we can proceed to find out what is the quadratic factor. So we got to do long division again. So it means 2x cubed minus 4x squared plus x minus 2. I'm going to divide it by x minus 2. Same thing, what times x give me 2x cubed? So it is 2x squared. So 2x cubed, this is minus 4x squared. So of course both of these is exactly the same, right? So it's 0. I'm going to bring down both of these, so it's plus x minus 2. So we know we need to multiply with plus 1. And of course, you must have remainder 0, because our x minus 2 is a factor. So now it means that I can say, oh, now my fx, I know that it will be x minus 2 as well as 2x squared plus 1. Can we factor the equation using calculator? Actually can. Because 5 marks. If it's a purely question asking you to factorize the 2x cubed minus 4x squared plus x minus 2, then cannot. You cannot just use the calculator and find out the 3 values or 2 values. For this case, you can only factorize one of them. I mean, you can only take out one term. The other one, calculator will not give you anything, because this one in calculator will give you imaginary number. Okay? So if you press the calculator, you will notice that you only get a 2. Then you cannot get the other 2 value. Okay, but in this case, because your objective is to express in partial fraction, so the factorization of the cubic, you can do it in short. Okay, but I can tell you, your calculator cannot solve this, because my quadratic factor, it is not factorized, are not able to factorize. You will have to still use long division in order to get the quadratic factor. Okay, calculator, you key in solving cubic equation, it give you the 2, yes, no problem. But the thing is, it cannot give you the other one. The other one, you will have to do long division. Okay, so then after that, After I factorize it, now I know that, okay, my task, I'm going to shift it. My task is to do minus 5x squared plus 11x minus 11 over x minus 2 and 2x squared plus 1. So now this is proper, right? And we already factorized the denominator. Now we're going to apply our case 1, case 2, case 3. So look at the denominator, x minus 2. X minus 2 is just linear, it's case 1. So it means that I will give birth to a over x minus 2. Now look at the second bracket. This is a quadratic. Quadratic, you've got to ask yourself whether you can factorize. So the bad news is this one cannot factorize. Oh, it means that I will apply case 3, which is a quadratic. So that means it will be plus bx plus c over 2x squared plus 1. Okay, now we're going to combine this into a single fraction. So it will be a will have to rainbow with 2x squared plus 1. Your bx plus c, please remember to put the bracket. It's supposed to be bx plus c rainbow with x minus 2. So common mistake is student put bx plus c bracket x minus 2 without the open bracket. Because this is supposed to be a big rainbow. If you don't put bracket here, imagine you don't bracket up the bx plus c. Then, technically speaking, when you rainbow, students always make the mistake. They rainbow the cx and minus 2c. Then they forget that the bx I also need to rainbow. You understand? So please remember to put bracket and rainbow it with x minus 2. So over x minus 2 and 2x squared plus 1. So now same thing, I want to look at the numerator. So I will say, therefore, my minus 5x squared plus 11x minus 11 is equals to a 2x squared plus 1 plus bx plus c and x minus 2. So again, of course, you can use compare coefficient or you can sub suitable value. Okay, so let me see. Let's see whether we have a suitable value to sub. Okay, I can sub in x equals to 2. So let's analyze. If I sub in x equals to 2 means this is 0, correct? 0 times this whole thing is 0. And I only end up with a. It means that I can solve a. So I'm going to sub in x equals to 2. So looking at this one as a reference, minus 5, 2 squared plus 11, 2 minus 11 equals to a square bracket 2, 2 squared plus 1. This one I don't have to write already because this whole thing becomes 0. Okay, I repeat, 2 minus 2, 0, 0 times this bracket, the whole thing becomes 0. So I don't have to write anything here. If you want to put plus 0 also can. Okay, next. So of course, press calculator. This side will give me minus 9. This will be minus 9a. So in the end, sorry, it's positive. So in the end, my a will be negative 1. So we're not done yet. We still have b and c to solve. So now look at the b and the c. The b multiply with the x. So it means that I can sub in x equals to 0. Okay, when I sub in x equals to 0, 0 times b will disappear, correct? But my c still remain. You understand? My a I don't have to worry because I already solved my a. I can just sub it in. So this time round, I'm going to sub in x equals to 0. Okay? So it will be minus 5, 0 square plus 11, 0 minus 11 equals to, my a is here already, so it's minus 1, 2, 0 square plus 1. See, plus b 0 plus c 0 minus 2. So what do I get here? This side I will have minus 11. 0 plus 1 is 1. Minus 1 times 1, so this is minus 1. b times 0 is 0. 0 plus c, so is c. Okay, this is minus 2. So it's c times minus 2, so this is minus 2c. Let's solve this. Bring the 2c over. So it's 2c equals to minus 1 plus 11. 2c equals to 10. c is equals to 5. So I solve my c. See, I have my a, I have my c. I only left with a b, correct? What thing y? I don't understand what you mean by y. Okay, so then after that, next is we can sub any x value I want. Okay, I already sub in 2 and sub in 0. So I'm going to sub in 1. Okay, so I can sub in x equals to 1 as well as my a as well as my c. So I will have minus 5 1 square plus 11 1 minus 11 equals to my a is negative 1, 2 1 square plus 1 plus b1 plus c plus 5, and then after that don't forget your x minus 2, so this one is 1 minus 2. So we will get minus 5 equals to minus 3 minus b minus 1. Okay, and eventually I will get my b equals to negative 3. So you see, I solved my a, I solved my b, I solved my c. So now I can break it up. Sure, after you do the question, can show the full questions. I want to take a screenshot. Okay, can, no problem. Provided I can show the full screen. Okay, later I break into 2 parts. Okay, wait. Okay, so anyway, I don't know whether you all know, you can the solution will be uploaded tomorrow, right, to my Telegram channel. So those who haven't subscribed to my Telegram channel, please go to my bio, click on the last button, that will go to my Telegram channel. Okay, so the Telegram channel, all the live PDF worksheets are uploaded there after the solutions. Okay, then the TikTok replay is uploaded to my YouTube channel. So YouTube channel is go to my bio, click on the second last button. So you can actually still get the worksheet from the channel. Okay, now let's see the where am I? Okay, so now I have my ABC. We're going to put it back to the fraction. So always write the original question. Okay, always write the original question, which will give us 11x minus 5x squared minus 11 over, write out the original question, will be equals to my a is minus 1, so it is minus 1 over x minus 2 plus bx plus c, so is this is minus 3x, so it will be minus 3x plus 5, right? So I will write it as 5 minus 3x over 2x squared plus 1, and we are done. Okay, so for you to screenshot, maybe this one I write proper fraction. Proper fractions. Okay, so this is the first part. Okay, you can take a screenshot. Then after that, moving up, this is the second part. Can? Oh, good. Okay, so we're going to do the third questions. I prepared a total of 3 partial fractions. Okay, after this question, we will start to do differentiation, maximum, minimum. So, if you are listening for the past half an hour, can someone tell me whether this is a proper or improper fraction? Is this a proper fraction or is this a improper fraction? Good. Okay, it's improper. Why is it improper? Highest power is cube. Denominator highest power is also cube. Remember I said if it's the same, it is still considered improper. So this is improper. So it means that we got to do our long division first. Okay, so let's do it. So 3x cubed plus 2x squared plus 4x minus 1. We're going to divide it by 3, 2, 1, okay. X cubed plus x squared. So what times x cubed will give us 3x cubed? 3. So this one times this one, 3x cubed. This one times this one, plus 3x squared. Minus, put bracket. Okay. And we will get 2 minus 3, so it's negative x squared. Bring this down. So this is plus 4x. Okay. And then this one bring down also. So that means this is the end already. You cannot further divide some more. Okay. How to know whether you can stop? Look at the remainder. The remainder power is 2. So the remainder degree is always smaller than the divisor. You see your divisor is x cubed. So my remainder is x squared. That means it's enough. That's already the remainder. You understand? Okay. So if you recall back, just now when we did this one, look at this one. When we divide by x squared, look at the remainder is x to the power of 1. Okay. The remainder degree is always smaller than the divisor. You understand? So now it means that I can put this into the so-called mixed number form. So it means it will be 3x cubed plus 2x squared plus 4x minus 1 over, I'm going to factorize the denominator. So take out common factor x squared, I will be x plus 1. So this will be equals to the quotient, which is 3, plus the remainder, which is minus x squared plus 4x minus 1 over the divisor, which is x squared, x plus 1. Okay, after doing the long division, you put it into the mixed number form. Okay, then again, all you need to do is, now you got to do the proper fraction here. So this one, I'm going to write it down here. So it will be minus x squared plus 4x minus 1 over x squared plus x plus 1. So now we're going to apply our case 1, case 2. Okay, this is a little bit tricky. Okay, so when students see x squared, they will think, oh, x squared, they were going to use the case 3, which is a quadratic, but it is wrong. It is wrong. Actually, x squared is repeated linear. It is actually x then square. It's called repeated linear. So actually case 2, it is, x squared, it is case 2. So this itself will give birth to a over x plus b over x squared. Okay, so this one actually give birth to 2 of these. This is repeated linear. Then after that, the last one, the x plus 1, is actually case 1, which is the linear. So it will be plus c over x plus 1. Okay, let's combine into a single fraction for this one. So my a, okay, see, my common denominator is x squared. Is x squared and x plus 1. So now let's analyze one at a time. So my a, the denominator is already have an x. That means it is missing an x and an x plus 1. So my a must rainbow with x and x plus 1. Okay? The b, the denominator is already x squared. So it's only missing a x plus 1. So my b must rainbow with x plus 1. Last, the c. The c already have x plus 1. So it's missing the x squared. So the c will be multiplied with x squared. Then now again, I'm going to compare the numerator. So therefore, minus x squared plus 4x minus 1 is equals to ax x plus 1 plus b x plus 1 and minus cx squared. Okay, so for this question, I will use compare coefficient. I will not use the substitutable value. Why? Because this one actually is just mini rainbow, right? So the rainbow, the expansion is not that tedious. So if it's not that tedious, we can use compare coefficient. And since my question 1 and question 2, I use substitutable value, so I shall use compare coefficient to tell you how to use it. So what you do is, you will just rainbow the right hand side. So this one times this one will give me ax squared. This one times this one, ax. This one is bx plus b minus cx squared. So this one just copy. So what I want you to do is, you shall group them in terms of x squared, x, and constant. If I'm going to take out common factor x squared, I actually have a minus c. Okay? Then take out x, I have a plus b. And lastly, plus b. So then now you will say, by comparing the coefficient, okay, you will see that, oh, the left hand side, my coefficient of x squared is -1. It means that a minus c is -1. So I have a minus c is equals to -1. Okay? And then I have my a plus b is equals to 4. So my a plus b is equals to 4. And lastly, easy, b is equals to -1. b is equals to -1. So since I already solved my b, I can sub b into here. So actually all I need to do is write equation 1, equation 2, equation 3. So we say I'm going to sub in my equation 3 into my equation 2. So it means it's a minus 1 equals to 4, a equals to 5. Then I'm going to sub in this into my 1. Okay, so I will sub a equals to 5 into equation 1. And I will get 5 minus c. So 5 minus c equals to -1. c equals to 6. So I solve my ABC. See, I have my B, I have my A, and I have my C. Okay, then now you can put back into this form. Always write the original question. So you say, oh, so therefore 3x cubed plus 2x squared plus 4x minus 1 over x cubed plus x squared is equals to, don't forget to bring back your 3. So it is 3. Then now it's this one. So my a was 5, right? So it's plus 5 over x. My b is -1. So it's -1 minus 1 over x squared. So it's minus 1 over x squared. My c is 6. So that means it's plus 6 over x plus 1. And we're done. Yeah, wait. Sorry, this one's supposed to be negative. This one bring over, this one bring over. Did I make a mistake? I think I did. Give me a moment. My c should be 6, -6. Did I make a mistake somewhere? Okay, anyone spot the mistake can let me know. I had a mistake. This one bring over, this one was a 6 one. Let me see where's my error. I should be -6. Okay, never mind. Later I check again. I should get -6. I don't know why I never get -6. Okay, never mind. Later then we see again. Okay, so let's see. Okay, we will continue. Can anyone spot the mistake so that we can resolve immediately? My B is -1, correct. My A is 5 is correct. My C is... I found my mistake. I saw my mistake. Yeah, I found my mistake. See here? Here is plus C. So this is plus. This is plus. This is plus. This is plus. And so this is plus. And so this is minus 6. Okay? Yes, got it. Okay? Okay, same thing. You want to snapshot, can take a snapshot. This is the first half. So this question I use compare coefficient. Okay, I use compare coefficient to let you see the two different methods. Okay, second half. Okay, so now we are done with improper fraction. So now we're going to do differentiation. Okay, we will do differentiation, application, maximum, minimum. Okay, so let's see. Okay, during exam, maximum, minimum is also one of the question whereby it's pretty easy to get marks. Okay, so make sure you master the maximum, minimum and get the marks from this particular topic. Okay, let's proceed. A piece of wire, they tell us that the length is 180 cm, is bent into this shape. Okay, so you just imagine the wire bent into shape. That means it's 13x plus 13x plus y plus 24x plus y will be equals to 180 cm. Agree? Okay, so that's the first thing that you can write. So you will know that 13x 2 times 13x plus y plus 24x plus y will give us 180. Okay, then you ask yourself, should I make x a subject or should I make y the subject? Look at the area here. Area is in terms of x, so you don't see y there, right? So you know that if you need an equation which is y as a subject, because you want to change your y to become x. So that's why I know I need to make y the subject. So let's analyze. So 26x plus 2y plus 24x equals to 180. 2y plus 50x is equals to 180. So my 2y equals to 180 minus 50x. My y will be equals to 90 minus 25x. We are not done yet. This is only the y subject in terms of x. We are supposed to show that the area is this. Okay, so then look at the diagram. How do you find area? Okay, you simply cut it into, this is a composite shape, right? So you will cut it into two basic shapes for this case. So I will cut it into a triangle and a rectangle. If I have the angle here, I can use half AB sine C, but I do not have the angle, so I know I have to use half times base times height. So in this case, I will just draw the height. Now, here is 24x. Do you agree this is also 24x? Here to here is also 24x. And for isosceles triangle, we know here bisect each other, so we know this one is 12x. And by Pythagoras Theorem, I'm going to do it this side. We know that the height will be equals to 13x square minus 12x square and then square root. You will get 5x. So our height is 5x. Understand? The height is 5x. The height is 5x. So now we will find the area. How to find the area? Area will be area of the rectangle, which is 24x, multiplied by y. This is area of the rectangle. Plus the area of the triangle, it will be plus half times the base, which is 24x. The height is 5x. So let's simplify this. Okay, so we get 24xy equals to half times 24 is 12. So this becomes 12x and 5x. So my A is equals to 24xy plus 60x squared. But we are not done yet. I want to make the y disappear. So how do I make the y disappear? I will have this. I will sub. This is equation 1. So I will sub 1 into 2. So my area will be equal to 24xy plus 60x squared, which we will get 2160x minus 600x squared plus 60x squared. When I simplify, I get 2160x minus 540x squared. And this is exactly as the one that they asked me to show. So we can say shown. Okay? See, the way of doing it is the same. Finding the area means, for this case, is I take the area of the rectangle plus the area of the triangle. Okay? Then you have extra y because they want it to be a in terms of x. It's okay. Okay? You can write a in terms of x and y first. Then after that, you know that, oh, my task is to make my y disappear. Then you look at the additional information that we have. Definitely there's a reason why they give us 180. So they tell us 180 bend into this shape. I add the parameter together, and I say that it's equals to 180. And because my objective is I want to make y disappear to become x, so I make y the subject. So I have y in terms of x. And that's where I will replace my y. My area got y just now, right? Here. So I was supposed to replace the y with the 90 minus 25x, which I have got it here. And my a will now be in terms of x. Okay? So, last part. Okay? Now I'm going to do my dA dx. So I'm going to dA dx. So I'm going to differentiate this. I will get 2160 minus 1080x. Okay, it's just differentiating this one. Then to get the maximum or minimum, we always do dA dx equals to 0. Okay, so, the differentiation equals to 0. So I will do for dA dx equals to 0, we will get 2160 minus 1080x equals to 0. So we get x equals to 2. So it means that, look at the question, they ask you to find the value of x and the y for which a is a maximum. So after I find my x, I need to find the corresponding y as well. I already have my x, and where's my y? My y is just 90 minus 25x. So my y is 90 minus 25x, and we get 40. So I actually solved my x, I already solved my y. Next is, I need to prove that it is a maximum. Okay, I need to prove that it is a maximum. So how? I can do my second derivative test. Because look at your dA dx, it's pretty easy to differentiate this one more time. So I'm going to do my d square a dx squared. So differentiate this, you get straight away you get negative 1080. And since this is a less than 0, so therefore we know that this is a maximum. Done. So I have proved that it is a maximum, and I have found the x and the y. Okay? So that's the answer. X is 2 cm, y is 40 cm, and a is a maximum. Okay, so that's for question 1. All good? Okay, so that's for question 1. Okay, any question for this? If not, I move on to the next question. Okay, so now let's take a look at, can teach me G1 Sec 2 math please. What is G1? Grade 1. Okay, anyway, let's move on. Question 2. Now they give us a diagram. They tell us that this is a poster with the area 850 cm squared, with side margins of 2.5 cm, and the top and the bottom. This should be bottom. Why is it button? Okay, and the top margins of 2 cm. The length and breadth of the printing area are x cm and y cm respectively. So your task is to find out, show the area of the printing area, which is the inside, is in terms of purely x. Do you see that? It's purely x, purely x. So let's find out. I know my A, which is the inside, will be x times y. Okay? But they want you to put it in terms of A purely with x. So it means that I need to make my y disappear, correct? So how do I make my y disappear? Look inside and see what other information you are given. You are given the area of this whole poster is 850. So it means that, let's find out what's the length of the poster. So my x is the length of the inside. Here is 2.5 cm, here is 2.5 cm. So the big length is actually from here to here. We will know that it will be x plus 2.5 plus 2.5, which will give us x plus 5. The breadth will be from here to here. We know the inside breadth is y. 2 cm means this will be y plus 2 plus 2. So this side is y plus 2 plus 2, so it will be y plus 4. So this is the breadth and the length of the poster, which they give us is 850. So I say, oh, okay, so I will know that x plus 5 multiplied by y plus 4 is equals to 850. So my task is to make y the subject. Okay, so this is multiply, right? So I will say y plus 4 is equals to 850 divided by x plus 5. Then I want to make y the subject, so y will be equals to 850 over x plus 5 minus 4. So do you see that I have y in purely x? So this is the equation 1, and this is the equation 2. So I will say, okay, I'm going to sub in my equation 2 into equation 1. Okay? So it means A is equals to x, y. So put a bracket, 850 over x plus 5 minus 4. And we go to rainbow this. Rainbow, and we get 850x over x plus 5 minus 4x. And do you see that it's exactly the same as this one? I have a fly here. The fly also want to learn math. Okay, so shown. And we are done. This part. Do you see how I link them together? Okay. So this is only part 1. Part 2. Same thing, they always ask the same thing. Now they say, okay, given that x can vary, find the value of x for which the printing area is stationary. Again, they say stationary. So I already have my A in terms of x, right? So I'm going to write it here. So A is equals to 850x over x plus 5 minus 4x. So I'm going to do my dA dx. Okay? The bad news is the first term, numerator got x, denominator got x also. And I cannot split it. So it means I have to use quotient rule. So I will have to keep bottom, which is x plus 5, differentiate the top, which is 850, minus keep the top, differentiate the bottom, which is 1, over bottom square. Then this minus 4x, when I differentiate, is just minus 4. Very straightforward. Okay, so I did the differentiation separately. I did the first fraction using quotient rule. I differentiate the minus 4x by using just rule 1, so just become minus 4. So now I'm going to simplify. So rainbow, I get 850x plus 4250 minus 850x over x plus 5 square minus 4. So this one minus 0, I left with 4250 over x plus 5 square minus 4. Your task is to find dA dx equals to 0. So we are not done yet. So you will say for dA dx equals to 0. So you have 4250 over x plus 5 square minus 4 equals to 0. So I'm going to bring the minus 4 over. So I end up having 4250 over x plus 5 square equals to 4 over 1. Cross multiply and solve it. Okay, I will skip the solving part. Okay, this one should be easy for you all by now. Okay, so I will solve. I will end up having the equation 2x squared plus 20x minus 2075 equals to 0. So this one you have to use the quadratic formula. So use the quad formula. So you will get x is equals to 27.596 or x is equals to minus 37.596. And we know that x is talking about the length. So we will reject the negative and we will accept this, round it off to 3SF. That's why it's 27.6 cm. 3SF. So they ask you to find the value of x for which is stationary. So I found it, which is 27.6. Okay, 27.6. Then the next thing is, explain if this value of x give you the largest or smallest. They're just trying to change the vocab. They are just asking whether this is a maximum or minimum. Okay, so you need to decide whether we're going to use second derivative test or use first derivative test. So how do we decide is look at your dA dx and see whether is it difficult to differentiate or not. I don't think this is difficult because I can just use chain rule. So I'm going to write out my dA dx first. So it is 4250 over x plus 5 square minus 4. I can rewrite this as 4250 x plus 5 to the power of negative 2 minus 4. So now we are ready to differentiate one more time. So power bring down, I will get minus 8500 x plus 5 minus 3. Differentiate minus 4 will disappear. So I ended up having only minus 8500 over x plus 5 cubed. So I need to sub in the x in order to find out whether this one is a positive value or negative value. So let's just sub in our x equals to 27.596. So my d square a over dx square will be equals to minus 8500 over 27.596 plus 5 to the power of 3. And we will get minus 8.000. This is less than 0 and therefore this is a maximum area. Okay, maximum area. And we're done. So answer is 27.6 and reject the negative 37.6 and it is a maximum area. They did not ask us to find the maximum area. They only ask you to determine whether is it a maximum or minimum area. So I do not need to sub into the original A to find my maximum area. Understand? So this is the question 2. Oh, good. Okay, let's move on to the third question. I will have a total of 4 questions. So I have 2 more questions for maximum, minimum, and then we will end the day. Okay. So, anyone still? Can I get some response? I want to know whether my channel is still working or not, or is it having some technical issue? And I also want to know whether anyone is listening or not. How anyone listening or not? If not, if nobody learning, then no point I talk, right? You're not listening? Then why are you still here? Please swipe away, thank you. So, sorry. Uh-oh. Okay. Trying to be nuisance, then you'll be blocked from my channel. Lor. Too bad. Okay. I have 12 viewers now, so is anyone listening in or not? Are you all still learning or not? If nobody is learning this topic, then I can just end my day early. Finish my work. I can go and watch my Netflix. Okay? I count to 5. Nobody respond. I will stop at question 2. 1. Good. Okay, so at least I can just talk. If nobody is listening in, then no point I continue to talk. Okay, so you are learning. Good. So let's continue and finish up the last 2 questions. Okay, this is quite a tough one. Okay, so open your ears big. Okay, the diagram shows a cone of radius blah 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 and height. It is given that the volume of the cone is 10 pi. Yeah, usually I just ignore, but I want to know whether anyone is listening in, because if no one, then I don't have to teach I can go and catch up my Netflix. I'm quite hooked to the Netflix. That show is so nice. You have to go and see. Unbelievable. Unbelievable. I mean, the show is called Unbelievable. It's a season with 8 episodes. Very nice. Okay. So over here, because they tell me the volume of the cone is 10 pi, so you will have to use the formula of volume of the cone. So I will write out volume of the cone, which is 1/3 pi r square h. Okay? Then, my volume is 10 pi, so put 10 pi here, equals to 1/3 pi r square h. So with this, you can see that both sides got pi, right? I'm going to cancel the pi. So divide by pi, I get 10 equals to 1/3 r square h. I see the 1/3, I'm also very irritated by it. So I'm going to times 3 throughout. So times 3, I get 30 equals to r square h. So now over here, I will wonder, do I make h the subject or do I make r the subject? So it's easy. Your task is to make a to be in terms of r. It means that it's purely r, correct? So you want to make the h disappear eventually. So it means that I have to make h the subject. So that means I will have h equals to 30 over r squared. Okay, we are not using this yet. Then after that, now, they ask you to prove that the curved surface area, take note, it is curved surface area. It is not talking about total surface area. If it's total surface area, you will have the curved surface area plus the pi r squared. But this is only curved surface area. So I highlight, this is only curved surface area. So I will have my A equals to pi r L only. Okay? And what is the L? L is this part. L is the slant height. So my pi r L, my L in this case, how am I going to put my L in terms of r and h? This is a right angle triangle. Okay, this is a right angle triangle. So it means that I'm going to form the Pythagoras Theorem. So it will be r squared plus h squared is equals to L squared. Okay, I'm going to make L the subject. So L is equals to r squared plus h squared square root. Okay, that's how I change my L to become r and h. Because my formula over here is only h and r. So the L is not helpful. So I need to so-called get rid of the L as well. So you see, this is very tricky. This is like 2 things, I have the L. I need to change it to become h and r. Then after that, when I did it to h and r, I need to change the h to become r again. So it's like 2 tiers, 2 tiers, Okay. So then after that, let's do it. So my pi r, then the L I put it here, so it becomes square root r squared plus h squared. Then now, this can start into here already. So I shall put this as equation 2. I say this is my equation 1. So I'm going to sub in 1 into 2, whereby I change my h to become r. So my A now become pi r square root r squared plus 30 over r squared squared. This is tricky. Why? Because there's a lot of square root, there's a lot of r square. So you need to be very careful with your manipulation. So let's continue. So my a will become pi r. This is r square plus 30 square is 900. R square square is r to the power of 4. Okay? Then after that, what do we do? Now you look at this. Okay? Let's see what we need to change first. So we can see that this side is combined into a single fraction. I'm going to combine the inside into a single fraction. So it is pi r. R2, if I want to change to the same denominator, is R4. So R2 times R4 is R6. So it becomes R6 plus 900 over R4. Okay? Then, because we can square root R4, so it becomes pi r multiplied with square root R6 plus 900 over square root R4. Okay? Square root R4 is just R square. So pi r multiplied by square root R6 plus 900 over R squared. Can you see that this is r and r squared? It means that I can cancel the r and left with only one r at the denominator. So now I have pi square root R6 plus 900 over r. And this is exactly what they want us to show. Do you see it's exactly the same now? Pi r R6 plus 900. Shown. Okay? Kids, during exam, if you let's say really panic and you're not able to do the part 1, please still go and take the formula and go and do the behind part. Because behind part, I don't need to say I already know what they want. They definitely will ask me to do the A, the R. Then after that, the A, the R equals to 0. Then I have to find out whether it's a maximum or minimum, right? So, if you cannot do the first part of the proving of the formula, you still can proceed to do the second and the last part. But don't try to do that. Some students, when they hear this, they happily just do the second part and the third part and just throw away the first part. Okay? Okay, let's move on. So, same thing, you see, given that r can vary, find the value of r for which a has a stationary point. So, I need to do my dA, dr. So, before that, I'm going to write out my a first, so it's easier for us to reference. So, this was the a. Okay? So, how am I going to differentiate this one? This one, if I'm going to use quotient rule, it's a bit tricky. So, what I'm going to do is, I'm going to change my a to in this form. Pi r negative 1 r6 plus 900 to the power of half. Okay, what I did was I bring the r to the top. When I bring it up, it becomes r to the power of negative 1. Then the square root, I don't want to see the square root, I put it as to the power of half. Why do I change to that? Because it's easier for me to do my chain rule. Okay, so now we are ready to differentiate. But the bad news, of course, I have to use my product rule. So let's do our dA, dr. This is not an easy one because it's quite complex. So try to catch it. Okay, keep left. Differentiate this one. So I'm going to apply chain rule. So bring down the half. R6 plus 900. Okay, bring down the half. Copy. Power minus half will become negative half. Multiply by differentiate inside, which is 6r5. Okay, plus, thanks for the rows, keep right, which is r6 plus 900 to the power of half. Differentiate the left. So I'm going to bring down the minus 1, so it becomes negative pi r negative 2. Okay, so what I did was, I keep left, I differentiate right, and this right I apply chain rule. I bring down the half, copy the bracket, power minus 1, half minus 1 is negative half, multiply by differentiate the inside, which is differentiate r6, which I get 6r5. Okay, plus, keep the right hand side, differentiate the left hand side, bring down the power, which is minus, so minus pi r, power minus 1, that's why it's negative 2. So I'm done with the differentiation. Now the tough part is how am I going to simplify? So you're going to take out the common factor. So like I've mentioned in the previous last time I teach the 5 rules, this is one term and this is a second term. So you need to see which is the common factor. Okay? So I definitely have pi on both sides. I'm going to take out pi. And how about the number? Okay, I will take out pi definitely. R minus 1 and R minus 2. Always take out the smaller one. So in this case, I will take out R to the power of negative 2. Okay, how about the bracket? Okay, negative half and half. Of course, negative half is smaller. So you will take out R6 plus 900 to the power of negative half. Okay, and that's all. I'm going to take out all these, put a big square bracket, and let's analyze. So the first term, okay, when I take out all these, what is my remaining? Okay, minus 1, big minus small, minus 1 minus minus 2, it's 1. Okay, so I will left with an error. Okay, I will left with an error, and not forgetting, I have a half times 6, which is 3. Don't forget I have a 5 here, so that means it will be 6. So I have 3R6. See here, what I did was, okay, this is minus 1, this is 5. Minus 1 plus 5 is 4. 4 minus minus 2, that's why it's 6. Half times 6 is 3. Yes, this is application of differentiation, maximum, minimum. Okay, then after that, nothing already, because this one take out no more already. Okay, now left, second term. So second term, I will left with a minus. Half minus minus half is 1. So I will left with R6 plus 900 to the power of 1, which I don't have to write. So now let's simplify. So I will have 3R squared. So this one just copy first. So I have 3R6 minus R6 minus 900. So I have 2R6 minus 900. All these, I'm going to bring it bottom, but I have a pi here, don't forget. So pi, I put it here, over R square, square root R6 plus 900. So this is not easy, This is not easy. Yes, it's actually combining all the indices and other stuff. Taking out common factor. The indices, right? Indices, I always make sure that my students are very, very good with indices. Okay? If they don't understand indices, I will make sure, they make sure that they understand indices before I move on to any other things. Because they are not going to survive if their indices is weak. So, next, we're going to do our dA dr equals to 0. So, for dA dr equals to 0, so this whole thing, it will be pi 2R6 minus 900 over R square, square root R6 plus 900 equals to 0. So I don't have to worry about the denominator, because when I cross multiply, denominator becomes 0 already. So I ended up having pi 2R6 minus 900 equals to 0. And divide by pi, I get 2R6 minus 900 equals to 0. So my R6 is 900 over 2. And then after that, R equals to 6 root 450. And we will get 2.768. Round it off to 3SF, 2.77. Okay, so now we are done with the first part. Next is determine whether is it a maximum or minimum. Okay, so for this, you see, look at your dA dr. Your dA dr is super complex, agree or not? If I'm going to differentiate my dA dr one more time, I think I will faint, okay? So in this situation, we will use first derivative test to find out whether is it, no, I don't think use d square a dr square is good, because it's difficult to differentiate this one. You see the numerator and denominator all got r. Okay, if I'm going to differentiate that one, I think it's very difficult. So we're going to use first test. So first test, we will use our table. We will draw table. So draw a table with 9 boxes. The stationary point was 2.768. So I can just put error equals to 2.77. So remember, we're going to sub something on the left and something on the right. So since this one is 2.77, I can just sub in r equals to 2.7. And the right hand side, I can just sub in r equals to 2.8. Remember, I said don't sub in too far away. Okay, just slightly smaller than the 2.77. Yeah, because you see, if you're going to differentiate this one, I also don't know how to differentiate. I need to, really squeeze my head to differentiate. Okay, so of course this one, we know that this one, dA dr is equals to 0, which is a horizontal. And for easier for me to sub in, I can just write out my dA dr here. To remind yourself that we are supposed to sub in the 2.7 and 2.8 into our dA dr to find out whether what is positive or negative. So my dA dr, it is pi 2r6 minus 900 over r square bracket, not brackets, that's square root. Wait, square root r6 plus 900. So I'm supposed to sub 2.7 into here. Replace all my r to become 2.7. And we will press calculator, you get negative. Just to let you know, this one, the value is actually negative 1.503. Just for information. You don't have to put. We only need to know whether is it positive or negative. No need so close 0.01. 0.1 is fine already. But there's another method, but it cannot always be used. Yes, usually I plus minus 0.1. Why not just use 0? No, don't put, remember my rule of thumb is plus minus 0.1. Don't plus minus, don't go to 0. Too far already. 0 is too far from 2.77 already. It's not so safe. I've explained before. Stationary point is like, okay, if let's say example, if I have a point here, this is my stationary point. You only need to know whether the slope here is up or down. So you only need to sub in a little bit to the left, a little bit to the left. Then after that, a little bit to the right to find out what's the slope. You understand? So you don't have to sub too far away. You understand? And you don't have to know the exact value. You only need to know whether is it positive or negative. So if it's a negative, means that gradient is negative, which is slope down. This one, you will get a positive value. For your information, I key calculator, I'll get 0.6875. So you know that this is a slope up. So in this case, you can see that this is like that, right? And therefore, we will know that it is a minimum. Okay, this is just what I don't need to draw here because I don't want to confuse you. Okay, and we will say this is minimum area at r equals to 2.77. Done. Understand? No, not yet. Not yet. Okay? Soon. Soon. I think the integral will be soon. Okay? Okay, next. So we are done with this question. We are now off to our last question. Question 4. Last question for the day. Yeah, some school already start integration. Soon. Maybe next lesson. Let me see whether what's the next list. 27. My next lesson is E-Math. I'm going to teach coordinate geometry and further trigo. So most likely will be next. That means next Sunday I will do some question on integration. Okay? Why? Is this actually useful though? Yes, rate of change is the hardest, I agree. But I have done the 4 questions on rate of change, right? So you all should be able to handle rate of change now. Yes, actually minimum maximum is quite really easy. Okay, now let's go on. Okay, Okay, again, same. You see, you can see that minimum maximum is always the same thing. They will ask the same thing, just playing around with the formula. So the diagram shows a container that is a hemisphere as well as a cylinder. Okay, by default, you all must know all the formula for the mensuration. Volume of sphere, volume of hemisphere, volume of cylinder. All this formula must be inside your head. You all must memorize because they will not give you the information. And if you don't have the information in your head, you will not be able to form the formula and you will not be able to manipulate. Okay. So they give me the volume of the container is 1215. So you look at the solid, you can see that the volume is a cylinder, which is pi r square h, plus the hemisphere, which we will know that it is 2/3 pi r cubed. So this is the initial formula for volume of a cylinder plus the volume of a hemisphere. So I plus them together. Next, you can look at before that, okay, you are supposed to make h in terms of r. Okay, h in terms of r. So it means that over here, fill in your 1215 first. So it will be 1215 pi is equals to pi r square h plus 2/3 pi r cubed. And you can see that all 3 terms have pi. So you're going to divide by pi. So I have 1215 equals to r square h plus 2/3 r cubed. Your task is to make h a subject. So I'm going to make r square h a subject first. So r square h will be equals to 1215 minus 2/3 r cubed. We are not done yet. I'm supposed to divide by r square. So I will do h is equals to, divide by r square will be 1215 minus 2/3. Okay, actually I can do this. 1 over r square, rainbow with 1215 minus 2/3 r cubed. Okay, I never put it as a denominator. Why? Because there's a 2/3 fraction already. If I'm going to put as over, there will be a lot of fractions. So I divide by r square is the same thing as multiply by 1 over r square. So now I know that I will have 1215 over r square minus 2r over 3. R square and r cubed, cancel the r square, I still have an r at the numerator, and then the 2/3. And you see, it's exactly the same. Shown. Thanks for the rows. Shown. Okay? Next, they ask you to show that the total surface area of the container is given by blah blah blah. So, total surface area, let's take a look at the solid again. So, my area, okay, let's take a look at the hemisphere. The hemisphere will be for a sphere is 4 pi r square. So, for a hemisphere is 2 pi r square. So, I have a 2 pi r square, which is the curved surface area of the hemisphere. The curved surface area of the cylinder will be plus pi dh. And then I still have a bottom circle, which I have to plus pi r squared. So this is the initial formula I have. Then let's massage a bit. Wait, can I explain the last part again? Which part? This part? So what I did was 1215 pi is given, is equals to the formula here. Then because all 3 terms has pi, so I divide by pi throughout. Okay, so I have 1215 r square h plus 2/3 r square. Then after that, because my task is to make h a subject, so I make this one the subject. I keep this positive. You see that this is positive? It means that if I keep this positive, I'm going to bring this to the left hand side. But of course I switch over lah. So it becomes r square h equals to 1215 minus 2/3 r cubed. And then after that, I want to divide by r square. So divide by r square is the same meaning as multiplying by 1 over r square. Okay? So 1 over r squared multiplied by this. If I rainbow in, I get 1215 over r squared minus 2r over 3. So how do I get 2r over 3? You see, this is r cubed. R cubed divided by r squared is r. That's why it's 2/3 r. And the r, I just put it to the top, because they write it in this form. Okay, so shown. Yuki, can? I hope you understand the last part. Okay. Okay, then now I already have the total surface area formula over here. Don't use big cap. My moderator might accidentally block you. Okay. Okay, so after that over here, you can see that my A is in terms of R. You can see that I want to make my H disappear, but I have a diameter here. So I need to change my diameter to R first. So it will be 2 pi r squared plus pi 2r H. So I'm going to make use of this one already. Put it in 1215 over r squared minus 2r over 3 plus pi r squared. So you see that now I'm putting A in terms of purely R. Okay, I'm putting A in terms of purely R. So of course I need to massage until it becomes exactly like this one, correct? So let's try. So what I'm going to do is, let's see. This and this is like terms. So I'm going to write this as 3 pi r squared first. So A is equal to 3 pi r squared. Okay. Now is I need to get this one. This one. So this one I can actually do rainbow. I will do this rainbow and then this rainbow. So how we're going to do this is, you can write at the side also, no problem. So I'm going to write at the side in case you all cannot see. So this is actually 2 pi r multiplied by 1215 over r squared, the first rainbow. So you can see that I can cancel the r. I left with only 1 r. So 1215 times 2 pi. So in the end, the first term become 2430 pi over r. Okay. Okay. Now the second rainbow. This one times this one. So I will get 2 pi r multiplied by negative 2r over 3. So over here, you will see that I will get minus 4 pi r squared over 3. Okay, do you see that? Okay, then after that, what do we do? If you notice, this and this is actually like terms. This and this is actually like terms. So A is equals to 3 pi r squared over 1 minus 4 pi r squared over 3 plus 2430 pi over r. So this one times 3, I will get 9 pi r squared minus 4 pi r squared over 3 plus 2430 pi over r. This one I just put at the side. And I will get 5 pi r squared over 3 plus 2430 pi over r. And because they are r squared, they put it in the middle, so just put it exactly as what they want. So 5 pi over 3 r squared plus 2430 pi over r. A. And this is shown. Okay. And the last part, again, by now you all should know what they want to ask, right? They will do dA, dr, then dA, dr equals to 0. So let's move on. So I'm going to write my A. My A over here is 5 pi over 3 r squared plus 2430 pi over r. So how to differentiate this one? No, you have to memorize the formula. Formula of those mensuration, the volume, total surface area, all these are not given. They are not given. So how do you differentiate this? I'm going to change this to r to the power of negative 1. So I will rewrite this as 5 pi over 3 r squared plus 2430 pi r to the power of negative 1. Now I'm ready to differentiate. So dA, dr, bring down the 2, so it becomes 10 pi over 3r bring down the negative one, minus 2430 pi r negative 2. So it will become 10 pi over 3r minus 2430 pi over r squared. Okay? This is my dA dr. But because later you want to do dA dr equals to 0, so it will be easier when you change them to the same denominator. So it means that my common denominator is 3r squared. So that means this will be 10 pi r multiplied by r squared minus 2430 times 3, then with a pi. And I end up having 10 pi r cubed minus 7290 pi over 3r squared. Now we're going to do dA dr equals to 0. So we will know that for dA dr equals to 0, 10 pi r cubed minus 7290 pi is equals to 0. I shortcut. Okay, I put like that. Okay, don't skip step. Okay, then I cross multiply 0 times 3r squared will disappear. So I ended up having 10 pi r cubed minus 7290 pi equals to 0. So my r cubed in the end becomes 7290 pi divided by 10 pi. And we get r cubed equals to 729. So my r equals to cube root 729. That will give us 9. And we're done. So that is the value of the r that for my a to be stationary. Okay? Next, determine whether maximum or minimum. Okay, I will use the secondary test because to differentiate this one is quite easy. So I will use this part. So I will do d square a dr square. I'm going to differentiate with respect to r. This one. This form. This form. So write out 10 pi over 3r minus 2430 pi r minus 2. So differentiate this one, I will get 10 pi over 3 plus 2430 pi r minus 3. And I have 10 pi over 3 plus 4860 pi over r cubed. So I need to sub in my r equals to 9, right? Because I need to know whether my d square a dr square is more than 0 or less than 0. So now I'm going to sub in r equals to 9. So my d square a over dr square will be 10 pi over 3 plus 4860 pi divided by 9 cubed. And we get 10 pi. So 10 pi is more than 0 and therefore we know this is a minimum area. And this time round, they did not mention that just find determine. They asked to find the stationary value of area as well. So this time round, I need to sub in my r equals to 9 into my a to find out what is my minimum area. Okay, so my minimum area will be equals to, you have to go back all the way to your a, which is here. So sub into a, and we will get 5 pi over 3, 9 square plus 2430 pi over 9. And we will get 1272.345, round off to 3SF, 1270 cm square. Done. 3SF. Okay, so you see we are done with partial fraction today, as well as maximum minimum of stationary point. Sorry, maximum minimum of for the differentiation application. Okay, so we are done for the day. Okay. SF 1272, right? I recently just come out with a video that I teach about SFR. Those who are not good at differentiation, rounding off significant figure, please go and see the 2 videos that I posted recently. 127, 7 is my third SF. The 2 tells me that I need to keep my 7. So I will be 127, but I cannot just round become 127, because 1000 plus, you cannot round off to 100 plus. So I have to put a compulsory 0 there. That's why it is 1270. Okay?